So this is the second part of section 2.1. I should get a new marker for this. And it's not necessarily harder. It's only finding an area of part of a shape. And what I mean, like if I gave you this square right here, and I asked you to find the area of only the part of it that's shaded, and not the entire square. Basically, I have a picture of a square with a circle inside of it, and the circle isn't shaded. Essentially, I'm trying to find the areas that I have labeled in pink, and usually to do this, I need to find two separate areas. One of the areas that I need to find is I need to find the area of the unshaded part. Of the unshaded part. And the unshaded part's a circle. In this problem, the instructions say find the area of the shaded region, use 3.14 for pi and round to 2 decimals. So for the unshaded part, it's a circle. And I know the area of a circle I can do by finding pi r squared. And in this case, I'm going to plug 3.14 in for pi, and I'm going to plug 8 in for the r. And the area of that is going to be 3.14 times 8 squared. And the area of the circle, the unshaded part, is 200.96, I'll say, square inches. I really don't need the units so far. Unfortunately, that's the area of the unshaded part. I need the area of the shaded part. And to find the area of the shaded part, I have to subtract two areas. So one of the areas that I'm going to need to find the area of the shaded part is the unshaded part. The second area I need is the area of the entire drawing, and I'll say as if it was all shaded. If this whole thing was shaded, it would be a square, and I'm assuming that the sides are 16 inches each, because the diameter of this circle would be 2 radiuses, which would be 16 inches. That would make this 16 inches, and in a square, all the sides are the same. So the area of the square, or if the whole shape was shaded, I can get by finding length squared, or side squared. The area of this is going to be 16 squared, which is 256 square inches. So I've calculated two areas. I've calculated the area of the empty part and the area of the entire shape. Basically, if I subtract the area of the entire shape minus the empty part, I'm going to be left with the area of these areas. Basically, I'm taking this area, subtracting the area of the circle from it, and that leaves me the shaded area. So the shaded area is always just going to be the subtraction of these two amounts. The area of the entire region was shaded, which is 256 square inches, minus the area of the unshaded. I'll say the area of the shaded is the area of the entire shape being shaded minus the unshaded part. So it's going to be 256 square inches minus 200.96 square inches. And I get 55.04 square inches as the area of the shaded area, the pink area that I have drawn. These are a little bit tricky, but they won't be so bad after we do a couple of them. So let me do 41 with you. So for 41, I need to find the shaded area. And the shaded area, I'll draw it in pink again. the area that I'm trying to find is all shaded in pink. First, I need to find the unshaded area first. And in problem 41, the unshaded area is a circle with a radius 4. So I'm going to use the formula area is pi r squared. I'm going to use 3.14 for pi because the instructions told me to do that. So I'm going to say the area is 3.14 times 4 squared. And I don't care to do that without my calculator. 3.14 times 4 squared is 50.24. Technically, the area of the unshaded part is 54.24 centimeters squared. I don't ultimately need to put units in until I get to my answer. The next thing I'm going to do is find the area, I'll say maybe of the big shape. Kind of if it was all shaded. So I'm going to find the area of this big old rectangle. And that rectangle, I get the area for it by using area is twice the length plus the width. The length is the longer of the lengths, the width is the shorter of the lengths. So if I shaded this whole thing in, I'd get a rectangle. The area of this rectangular shape is going to be 2 times 18 plus 12. It's going to be 60 centimeters squared. So my answer, the shaded area that I'm trying to get, is always going to be the bigger number minus the smaller number. So it's going to be 60 centimeters squared minus 50.24 centimeters squared. So 60 minus 50.24. And I get 9.76 square centimeters. So my answer is the area, the shaded area, is 9.76 square centimeters. Double check that to my answer in problem 41, and I'm not feeling so really comfortable about my work right now. So what did I do wrong? I didn't do something right here, huh? 2 times 18 plus... Oh, I used the wrong formula. Oh, idiot. So, big mistake. So this was really beneficial that I took the time to check myself. Because I checked myself, I have a mistake, I don't feel like redoing this. This is a perimeter formula. Here I should have said area is length times width, and the length and the width are the 18 and the 12. I should have said area is 18 times 12. Sorry about that, but that's okay. This is a nice thing about being able to check your work. I should have said area is 216 of the rectangle square centimeters. And for my answer, I shouldn't have subtracted 60, which is the perimeter. I should have taken 216 minus 50.24. And I'd get the 165.76 centimeters squared. Super easy, super easy to make silly mistakes like that. Happens all the time, even when I write my keys to my test. So I try to be kind when I grade. I really don't like taking points off. So if you're going through and you do something silly like this, you have the concept right. I'm supposed to take two areas and subtract them, and you use the wrong formula to find one of the areas. You know, if it's a 6-point problem, I wouldn't take off more than 3. All right. So 43 and 44, we have an outside ring that we need to find the area of. First thing I need to do for problem 44 would be similar to the first thing you need to do for problem 43 is find the area of the unshaded portion. The area of the unshaded portion for you is going to be a circle, and it has a radius of 5 feet. For me, my unshaded portion is going to be a circle that has a radius of 7 feet. So first I'm going to do the unshaded area. And it says leave my answer in terms of pi. It's because all the shapes are circles and it's okay to have pi. So my unshaded area, I'm going to do A equals pi pi r squared. And I'm going to put 7 in for the pi. So I'm going to get a equals pi times 7 squared. And I'm not going to put my units into the end because they kind of mess me up. So my area is 49 pi square units. Now I'm going to find the area of the whole big shape. The big shape here is a circle. So I'll say the area of the entire large figure, with not including the whole. That's going to be a circle with a radius of 14. So that area is going to be pi, and its radius for the big circle is 14. So pi times 14 squared. Your big circle has a radius of 10 feet. So my large figure has an area of 196 pi square centimeters. The shaded area is always going to be just found by subtracting the large area, 196 pi, minus the smaller area, 49 pi. To do that, you just subtract the numbers and leave the pi like an x. So 196 minus 49 is 147. My answer, the shaded area, I don't need to write shaded area, I'm going to have 147 for the number, pi for the symbol, and its area, so I need square, in this case centimeters. For your problem 43, apparently you should get 75 pi square feet. I'll walk through 45 with you and skip 46 because I think it's a little bit challenging here. So for the unshaded region, I need to do first. So for number 45, I need to get the area of the unshaded part, and I'm assuming these lengths are in meters. I'm also assuming that these, I can't maybe assume that. Can I assume that? Maybe not so much. Let me look at my answer for 45. I don't think so. Okay. I'm not sure what I assumed. So let me find the unshaded region. And the unshaded region, it looks like a square to me, but maybe it's not a square. So real quickly, at least I have to assume that I'm going to assume I need to find the length of this side right here. And I don't know that it's 7. So I'm going to take out from my picture this. This is going to be a right triangle. I'm assuming this is a right angle. It doesn't look so right on my drawing. And I'm going to use the Pythagorean Theorem to find this side right here. I'm going to call this side A, this side B, and this side C. I'm going to round to 2 decimals. I'm going to go A squared plus 7 squared equals 10 squared. This is going to give me A squared plus 49 equals 100. I'm going to minus 49 from both sides. I'm going to get A squared equals to 51. So A, that other side, is going to be super close to 7. That's why it looks like a square. But that side is actually the square root of 51. And I'm going to write 7.14. So what I have is not a square. The unshaded part is a rectangle. And the area of the unshaded part, because this is a rectangle, the unshaded area, I'm going to get by using the length times width formula. But I didn't know what this length was. I couldn't just assume it was 7. So my unshaded area because it's a rectangle, I'm going to use the length times width formula, and I'm going to do 7 times 7.14 for that area. So 7 times 7.14, I get 49.98. I would have gotten 49 if I used 7 for that. Alright, got the unshaded area down, and now I need the area of the entire shape. That's the easier part. This entire shape is a circle, that has a diameter of 10 for the area of the big shape because it's a circle. I'm going to use the pi r squared formula. I'm going to use 3.14 for pi. The diameter is 10, so the radius is 5. So I'm going to go area is 3.14 and then times 5 squared. So 3.14 times 5 squared. And I get 78.5 square meters. Unfortunately, I'm not done because I always have to subtract. So I found an unshaded area. I found the area of the large shape. The shaded areas will be the difference between the two. And my shaded area is going to be the 78.5 minus 49.98. I'm going to need units. It's going to be square meters. So 78.5 minus 49.98 equals, and I get 28.52 for the number, and that's not the answer that I have on my key. I think my key is wrong because I didn't realize that this wasn't a square. I didn't think deeply enough when I did the problem. The area here should be 28.52. And then units are meters. It's area, so it's square meters. I think when I initially wrote my key for 45, I didn't even think about it. I left this as a square that was 7 by 7. And if you would have done the unshaded area as a square that's 7 by 7, this would be 49, and then you'd get the answer that I came up with. But this is more correct, so I should go through and change my answer because that feels good. Wouldn't ask something like that on a test, so I wouldn't fret too much about problems 45 or 46. But I think that's how it should be done. 47 and 48 are similar but kinder problems. So because they're exactly the same, heck, pause the video and try to do 47. I'm going to do 47 and not 48. I need to calculate two areas. The first area I'm going to do in problem 47, I'm not going to do 48. The unshaded area, that's just a lovely square. So the unshaded area is a square, and the area of a square is you just square the length of the sides. So the unshaded area is going to have an area of 4. Unfortunately, the whole shape, the big area, the big shape itself is a circle. And I'm going to use the pi r squared formula to get the area of that, but I don't know right there. I don't know the radius. I can find the diameter. So I'm going to look at what I have drawn here. And inside the circle, I have a triangle. And I know two of the sides of the triangle. The diameter is the distance across here, which I can get by using the Pythagorean Theorem. I'm going to get the diameter, and then I'm going to divide by 2 to get the radius. So let me do some work right here to find the diameter. To do the diameter, I'm going to say a squared, I'm going to call that 2 squared, plus b squared, I'm going to call that 2 squared, equals d squared. This is going to be 4 plus 4 equals the diameter squared, or 8 equals the diameter squared. I'm going to square root and square root. I'm going to round to 2 decimals. So I'm going to go second square root of 8, which is 2.83 if I round it properly, equals the diameter. I'm going to divide that 2.83 divided by 2 to get a radius, because a radius is always half a diameter, and I'm rounding to 2 decimals again and getting 1.42. It's dangerous, dangerous, dangerous to be doing as much rounding as I did. I rounded to find the diameter, I rounded to find the radius. If you round differently, you can get an answer that's slightly different. Nevertheless, this is the radius for the big shape. So the big shape has an area. I said use 3.14 for pi, so 3.14 times 1.42 squared. So 3.14 times 1.42 squared. And I'm going to round that to 2 decimals. I'm going to get the big shape has an area of 6.33. The small shape has an area of 4, and the shaded area I always find by subtracting these two amounts. So my shaded area, which is going to be my answer, is going to be the 6.33 area minus the 4 area. I could do that. That's just 2.33. The units are supposed to be in meters, so I'm going to say square meters, and that's going to be my answer to this lovely problem. All right, I think the problems back off and get easier again. We've got 3 more problems to get through. 50 is kind of a relief. 49 and 50 are essentially the same. Let me do 50. For 50, the unshaded area is a square that's 5 by 5. The area of the unshaded part is 5 squared, or 25. The big shape is a rectangle, and its area is just length times width. Oh, it's a square, actually. Its area is 13 squared, which is 169. The shaded area is just the difference between the two. My shaded area is going to be 169 minus 25. That's going to be 144. I need units, and I'm going to put square centimeters. So my answer to problem 50 is the shaded area is 144 square centimeters. I'm assuming, and not that it's the best drawing in the world, but for your 49, your big shape is a square that's 15 millimeters by 15 millimeters. Your small shape is a square that's 5, your unshaded shape is a square that's 5 millimeters by 5 millimeters, so that your problem is supposed to be essentially the same as mine. I'm going to walk through 51 with you. I don't put 52 on the test, and 52 is actually a lot easier than 51. In 51, I need to find the area of this shape right here. This is tricky for a lot of students because the lengths aren't given to me. Let me find first this length right here. And to do this length right here, the whole length of this side is 15 because opposite sides have the same length. So this whole length in a rectangle is 15. 4 of it's taken up here. The difference between the 15 and the 4 gives me 11 for this side of this length of the rectangle. These two sides together add up to 15, which is the opposite side. Similarly, when I go to get this side right here, the whole length I think is 30. The small part of it is 8. The difference between 30 and 8 is 22. That's going to be the short, or the length of the rectangle in here. So these two sides, 22 and 8, add up to the 30. That's the opposite side. And these two sides, 11 and 4, add up to the 15. That's the opposite side. So the unshaded shape right here is a rectangle. And an area for a rectangle is length times the width. It's going to be 22 technically centimeters times 11 centimeters. And that's 242 centimeters squared. So the unshaded part has an area of 242 square centimeters. The big shape is this big rectangle here. And its sides are 15 by 30, so its area is going to be 30 centimeters times 15 centimeters. And that's 450 square centimeters. For the shaded area, you just subtract the 2. I'm going to take the 450 square centimeters minus the 242 square centimeters and get 208 square centimeters. Square centimeters for 51. So my answer the shaded area is 208 centimeters squared. I didn't show the answer for 49. I got 200 square centimeters. I did 47 with you. So one last problem to do, 53 and 54, which are kind of the same problem. I'm assuming that to find the unshaded region, that the circles can be put on top of each other. So I could take this circle right here and attach it to this circle, and my unshaded region becomes just a circle. So in my problem, I could take this circle, line it up with this circle, and the unshaded region is just going to be the area of a circle. So when I go to do problem 54, for the unshaded part, I have two half circles, which is a whole circle. I'm going to use the area of a whole circle, which is pi r squared. Your r is 6. My r is half of 11. And 11 divided by 2 is 5.5. So for the area of my unshaded part, I'm going to use 3.14 for pi. And I'm going to use 5.5 for the radius. I'm going to round to 2 decimals. 4 times 5.5 squared. I'm going to say 94.99 for the area of the unshaded part. The big shape, the whole shape itself is a square. So the big shape, or the big area, is just going to be a square. And to find the area of a square, you just square the sides. My area is going to be 11 squared, which is 121. When you go to do your problem for the big area, I'm going to assume that each one of your sides is 12, because each one of your sides will kind of have 2 radiuses. So you get a 6 here and a 6 here, which is a 12. And I'm assuming it's a square that's 12 on each side. For my shaded area, I subtract the 2, the unshaded part minus the big part. So my shaded area is going to be 121 minus 94.99. And I'll get 26.01. And then square inches. So my answer needs to be 26.01 square inches. When you go to write an answer for your problem 53, I got 30.96 square centimeters. I didn't have units on the drawing, so it just says assume the units are in centimeters. So that's everything for area. Next step is doing volume. You could move on to the volume even if you don't have these problems perfected, because you don't have to have area perfected before you do move on to volume. It's really these shaded area ones that are the tough ones. So if you need me to do some more in class, I absolutely have time to do that.